Hello and welcome back to Algebra fans. Today we are starting chapter 9, which is all about solving quadratics. We're going to take today 9.1 and it's going to be mostly review, okay? So this is kind of a long video, but at least half of it is review from chapter 6 when we were working with exponents and properties of radicals. So our essential question is, how do you simplify radicals? You know a square root expression is in the simplest form when the radicand has no perfect square factors. What are perfect square factors? Well, those would be numbers 1, 4, 9, 16, 25, 36, 49, 64, 81. You get my drift, right? So, for example, 4 would be, or 100 would be 10 times 10, right? So if you had 200, for example, the square root of 200 should be 10 root 2. So you want to make sure that there are no perfect square factors, aka none of these. The second way you know, the radicand has no fraction. If you can get rid of it, get rid of it. 8 over 4 is really 2. And then the third thing, there are no square roots in the denominator. All right, we do not want to have square roots in the denominator. You remember that from back in lesson 6.2. Now, it was way back in February, but I have confidence in your memory. So we're going to do 2 examples together. All right, we're going to do 2 examples together. And I'm going to have you try the rest on the page. We're pretty much going to do 1 example, maybe 2 per page. So it's going to take us a little while, but like I said, most of this is review. So our first example here, we have 2 over 72, and we're taking the square root of the whole thing. First, we can simplify the fraction. So let's do that. Simplify the fraction. So both 2 and 72 are divisible by 2. That means I would get 1 over 36. The next thing I want to do is I know this square root can apply to the numerator and the denominator. So square root of 1 and then the square root of 36. And then we are going to take the square root. Well, the square root of 1 is 1 and the square root of 36 is 6. Be careful, because it could have been negative 6 squared or positive 6 squared. So this is technically a plus or minus negative 1/6. Sometimes big ideas will give you that plus or minus option, sometimes it won't. So I just want you to remember that that could be the case, right? It could be the case. Let's take a look at the one on the far right here. X squared plus 8x plus 16. Let's factor this. So what multiplies to 16 but adds to 8? Well, the factors of 16 are 1 and 16, 2 and 8, or 4 and 4. Hey, wait a second. 4 plus 4 is 8. So x we know is our first term, and then we must have plus 4 plus 4. I can FOIL this out, and I would see that I would get exactly x squared plus 8x plus 16. Hey, it's like we spent a whole chapter doing that. Whoa, that comes in handy, doesn't it? Well, I can rewrite this because I notice that I've got x plus 4 times x plus 4, so that's really x plus 4 squared. Hey, wait a second. I'm square rooting a squared. That's like they cancel out, right? So we're left with just x plus 4. All right, I want you to try the middle one here and then these 3. Pause the video, try those, see what you get. All right, you should have gotten for your answers plus or minus 5, plus or minus 8, plus or minus 7, and 3 minus x. That's what you should have gotten for your answers. We're going to flip the page over for page 2. All right, on page 2, we are using a product property to solve square roots. So the first step to these, we want to break whatever we have into the prime factorization. We are going to make pairs of whatever is in prison, aka inside our square root, right? Then we want to see who escaped and who got left behind. So we're starting right here with square root of 18. Well, square root of 18 is really 2 times 9, but 9 is really 3 times 3. So our prime factorization for 18 is 2 times 3 times 3. Then we asked ourselves, do we have any pairs? Yes, 3. 3 can escape. So who escaped? 3. Who got left behind? 2 did. He didn't have a buddy to escape from jail with. So our final answer, or our simplest form for this radical, is 3 root 2. Our next one here, we've got the x to the 4th square rooted and y cubed. So that means I have 4 x's, because it has an exponent of 4, so that's x times x times x times x. And then how many y's do we have? What's the exponent? Yeah, 3. So I've got 1, 2, 3 y's. Now we need to make pairs. Buddies who can escape. Maybe they dig a tunnel together. We've got one x who can escape, another x who can escape, and one y who can escape. So who gets left behind? A y does. So that means we have x that escapes, an x that escapes, a y who escapes, and a y left behind. We can combine our x's to get x squared times y times square root y. So that is our final answer. This should be in alphabetical order, right? X comes before y, just to remind you. For our next one here, 128. Let's do the factorial tree for 128. We have 2 times 64. 64 is really 2 times 32, which is really 4 times 8. Neither of those are prime, though. 4 is really 2 times 2. 8 is really 2 times 4. And 4 is really 2 times 2. So we have 1, 2, 3, 4, 5, 6, 7 2's here. 2 times 2 times 2 times 2 times 2 times 2 times 2. Let's see which 2's can escape. He has a buddy, he can escape. He has a buddy, he can escape. He has a buddy, he can escape. He does not have a buddy. So we have 1, 2, 3 2's that escape, and 1 2 that gets left behind. Well, 2 times 2 is 4, times 2 is 8. We can also write 2 cubed root 2, or 8 root 2. All right, I want you to try the rest on this page. Pause the video and try the rest. You should have gotten xy root x, 4a root 3b, 6 root 5, 2 root 10, 18 root 2, m squared n, square root mn, 4x squared y, square root 2y, 10a, square root 2b, and then z squared y, x cubed, square root y. This actually needs to be rewritten because we have to write it alphabetically. So x comes before y, comes before z. So x cubed y, z squared, square root y. Email me with questions. Let's look at page 3 of 10 now. All right, page 3, using the quotient property of square roots. The general rule here is if you can simplify the fraction, do it first. Our first problem here, we've got square root of 5 over 9. 5/9 we cannot simplify, right? It's as simple as it gets. They're both odd numbers. Nothing goes into both of them. So I'm going to take my square root and I'm going to apply it to my numerator and apply it to my denominator. And we know that the square root of 5 is not a pretty number. 5 is somewhere between 4 and 9. The square root of 4 is 2. The square root of 9 is 3. So it's some 2 point something decimal, somewhere between 2 and 3. So I know my numerator is going to stay just a square root 5. But 9, remember, we do not want to have radicals in the denominator, and we know what the square root of 9 is. It's going to be plus or minus 3. I'm going to leave it as just a positive. It says up here, assume that all variables represent non-negative numbers. So technically this would be plus or minus 3, but let's just leave it as a positive for now. All right, let's do the next one. If you can simplify the fraction, do so. So we've got an a to the 5th over 81a. Hey, look at that. I have a's in the numerator and denominator. Our quotient rule from way back in 6.1 says that I would subtract those exponents. Well, our denominator has an exponent of 1. So this would be a to the 5th minus 1 over 81. And I'm taking the square root of the whole thing. Well, 5 minus 1 is really a to the 4th over 81. And I'm square rooting each of those. Well, the square root of a to the 4th is a squared. And the square root of 81, what times itself makes 81? 9. So this is a squared over 9. All right, I want you to try the rest of this page. Pause the video, try the rest of the page. All right, you should have gotten 2/3 for the next one. 6 over x squared, y cubed over 2, square root of 17 over 5, square root of 7 over 4, square root of 6 over 7, square root of b over c, square root of x over 3, square root of 7a over 3, and then x root x over y cubed. You'll notice that none of those have radicals in the denominator. So that's how you know they're in the simplest form. And we flip over to page 4. So we want to use the product and quotient properties of square roots to simplify the following. Don't forget your square roots. Right here are your squares, I should say, right? Those are all nice squares. First thing you want to do is make sure you write out the prime factorizations, and if you can, make sure that everyone escapes from the denominator first, so that you don't have anyone left behind. So our first example here, we've got square root of 80 divided by 25. So that's the square root of 80 is really 2 times 40. 40 is really 2 times 20. 20 is really 2 times 10, and 10 is really 2 times 5. 25 is really 5 times 5. Now, I could cancel out these 5s here, right, and reduce my fraction, but I'm going to escape the denominator first. So down here, these 5s have a buddy to escape with. So they can escape from prison in my denominator. So now that I've escaped them, I can look and see if there's anything else, because I have nothing in the denominator, right? So now let's look at what's in the numerator who can escape. Well, these 2's can escape, and these 2's can escape, and my 5 does not have a buddy. So I have 2 2's, or 2 squared, and then 5 gets left in jail. Another way of writing that would be 4 root 5 divided by 5. Now remember, this 5 is just visiting. The 5 in the denominator is just visiting. The 5 in the numerator is stuck in jail. I cannot cancel them. They are different, all right? So my final answer is 4 root 5 over 5. Let's take a look at our second example here. So 4x to the 5th divided by 9. I am going to write out my prime factorizations. So 4 is really 2 times 2, and it says I have x to the 5th, so I need how many x's? 5. X times x times x times x times x. Over 9. Well, 9 is really 3 times 3. Again, escape the denominator first if you can. Hey, this 3 has a buddy. They can get out together. Dig a hole, or however they escape from jail. Then we look at our numerator. Who has buddies? Well, this 2 has a buddy to escape with. So does this x, and so does this x. Does anyone get left behind? Yes. This x gets left behind. So we have 2 times x who escapes, and the x gets left behind. Well, that's really 2x squared root x over 3. Can't simplify it anymore. All right, try the rest of the problems on this page, and we will go over it in just a minute. Try the rest of the problems on this page. All right, you should have gotten 2 root 5 over 7. Z squared root z over 5y, p cubed divided by q to the 5th, 5x root 2 over 13. Let's write it. Square root of 169 is 13. All right, let's look at our next page. All right, we're looking at cube roots now. Cube roots. There's a typo with this first one. It should say negative 125, the cube root of a negative 125. Remember, with cube roots, that means our gatekeeper is a 3 now. Not 2, but 3. So in order to escape, we have to have groups of 3. So for our 125, I'm going to do the prime factorization. That's really 5 times 25. Well, 25 isn't prime. It's really 5 times 5. So this has a negative here, though. Well, that means I could have negative 5 times a positive 25. But positive 25 could be negative 5 times negative 5. That means that negative 125 is really negative 5 times negative 5 times negative 5. And in order to escape, I need groups of 3. Hey, look at that. I have exactly one group of 3 negative 5s. So the cube root of negative 125 is negative 5. It's not plus or minus, it really is just negative 5. That's the only thing times itself 3 times will get you negative 125. I'm going to skip the middle one right here and have you do that one on your own. Let's take a look at the far right. So this far right one is the cube root of y divided by 216. Well, 216 is really 2 times 108. 108 is really 2 times 54. 54 is 6 times 9, but neither of those is prime. 6 is really 2 times 3, and 9 is really 3 times 3. So when I write out my prime factorization, I am going to have the square root of y divided by 2 times 2 times 2 times 3 times 3 times 3. In order to escape, this is a cubed root, I have to have 3. Hey, look at that. I have 3 2s. They can escape. And I have 3 3s. They can escape. My y has no one. So my numerator stays the cubed root of y, but in my denominator, I have a 2 and a 3 that escaped. Wait a second, 2 times 3 is really 6. So I have the cubed root of y divided by 6. Try the next 4 on this page and see what you get. Pause the video, try the next 4. All right, you should have gotten 5x squared times the cubed root of x. He could not escape from jail, he didn't have a buddy. 2x, the cubed root of x, divided by 3y. 3 times the cubed root of 2. And then c squared d times the cubed root of 25c divided by 4. This 25 has a buddy, right? 5 times 5, but we had to have groups of 3 to escape, so he couldn't escape. So he got stuck inside prison still. Email me if you have questions. Rationalizing the denominator is the next page of our notes, and this is a little new. We've looked at it a little bit before, and you're going to see it a ton when you get to geometry next year. So get familiar with it, get comfortable with it, all right? Get familiar, get comfortable. First thing you need to know, square roots do not stay in the denominator, all right? It's like one of the worst faux pas in math. It is a fashion no-no, like leaving the house in our sweats. Don't do it unless you're going to go work out, and even then, ew. So we want to simplify each quotient. We cannot simplify the square root of 2 in this one. We've got square root of 7 divided by square root of 2. Even if I do a prison transfer, 7 does not divide by 2. So there's no way to make that simpler. So in order to get rid of the radical in my denominator, I know that I can multiply anything by 1 and have it stay the same. 1 times x is still x, right? Well, remember, if you have anything divided by itself, it's 1. So that could be a divided by a. That's equal to 1. Or you could have 7 divided by 7, that's equal to 1, or root 2 over root 2. Anything divided by itself is still equal to 1, and timesing anything by 1 does not change the value of the problem. So, to get rid of a radical in your denominator, we're going to multiply by whatever it is in the denominator over itself. So root 2 over root 2. And then, to multiply fractions, I just multiply straight across, right? So we have square root 7 times square root 2 over square root 2 times square root 2. Now, this is like a prison transfer going on, right? So I can put my 7 and my 2 together. So 7 times 2 over, and I can do a 2 times a 2. And then we can look and say, hey, is there anyone who now has a buddy who can escape? Yeah, our denominator suddenly does. So our numerator does not. 7 and 2 are not buddies. They can't escape. They're not the same. So we get square root of 14. But we have a 2 in the denominator that can get out. So our final answer is going to be the square root of 14 divided by 2. That is as simple as it gets. All right, let's take a look at the next one. Square root 7 divided by square root of 8n. Let's see if we can simplify this at all. I know that 7 and 8 are not going to simplify, but I might be able to find some pairs that can come out of the 8. So let's do our prime factorization for our denominator. We've got root 7 in the numerator. 8 is really 2 times 4. 4 isn't prime. 4 is 2 times 2. And then we've got our n on there. Hey, look at that. There's a 2 that can escape. So I've got root 7 in my numerator. 2 escapes, and then I'm left with 2n. That makes it a little easier and a little simpler when I go to rationalize the denominator, because I cannot have this square root 2n. So I'm going to multiply by root 2n over root 2n. Again, it's multiplying by 1. I'm not changing the value of anything. So now, in my numerator, I have 7 times 2 times n, because I just multiply straight across, just like with fractions. And in my denominator, I have a 2 that's visiting, and then I do my prison transfer, so I have 2 times n times 2 times n. So now let's see if there's anyone who can escape. Well, I've got a 2 in my denominator that can escape from prison, and I have some n's that can escape as well. So my numerator is 7 times 2 times n. Well, 7 times 2 is 14 times n. And in my denominator, I have a 2 that can escape. I have a 2 that was already visiting, and I have an n that escapes. So that's really square root of 14n over 2 times 2 is 4n. I want you to try the rest of the problems on this page. See what you get. Try the rest of the problems and see what you get. Pause the video. All right, you should have gotten 65, square root of 65, divided by 5. Square root of 21a divided by 6. 8 square root of 35 divided by 7. And the square root of 26 divided by 2. Again, email me with questions. We've seen this a little bit before, but, we're clearing out cobwebs, and that's okay. Let's look at the next page. All right, we are adding and subtracting square root expressions. All right, adding and subtracting square root expressions. So with this, we want to remember that we can combine like terms. We haven't seen this before, okay, so this is kind of weird and different. Remember that if you have a variable x, for example, x is like any other x, right? If you have 2x, it's like 3x, it's like 4x. Same thing applies with roots, all right? The square root of 7, for example, is a like term to square root of 7. Things that are not alike are if they have different exponents, so x is not like x squared, or if the radical is different itself. So like square root of 2 is not like square root of 11. And we kind of know that, right? We know that square root of 2 is going to be some value between 1 and 2, and the square root of 11 is going to be somewhere between 3 and 4 because it's between 9 and 16. So we know that those two things are not alike. So when we're looking right here at our very first problem, we have 3 root 7 plus 8 root 7. Both of these have root 7s. So I can just ignore that for a second and just think about, well, if I have 3 of some box plus 8 of the same box, how many total do I have? Well, 3 plus 8 is 11. And then I just tack my root 7 on. So this is like having 3x plus 8x, right? It's the same idea. It's just that we have square roots instead of a simple variable. But it's the same idea, because that would be 11x. In this case, we had 11 root 7. I'm going to skip the middle one here for you to try. Let's take a look at this one over here. So we've got 12 root 2 minus 4 root 11. Are they like terms? No, they are not. Root 2 is not like root 11, excuse me. It's not like root 7 either, though. So the simplest this can go is 12 root 2 minus 4 root 11. We cannot combine. That's as simple as it gets. So let's look at our next one, which is the middle left over here. I have negative 8 root 3d plus 6 root 2d plus 10 root 3d. All of these roots have d in them, but only 2 are 3d's. This one is a 2d, so I can't do anything with him. I'm just going to leave it as a plus 6 root 2d. I cannot combine him with anything else. 2d is not like 3d. They are not the same. Two-dimensional, three-dimensional, very different. So negative 8 root 3d plus 10 root 3d. Negative 8 plus 10. Negative 8 plus 10. That should give us 2 root 3d. And then our plus 6 root 2d just hangs out. So that's as simple as it gets. Try the rest of the page. All right, try the rest of the page. Combine them, simplify them. All right, you should have gotten 8y for the top middle. Negative 7, root 7, or negative 1 root 7 for the middle. 3 root 3 for the middle right. 8 root n for the bottom left. Root 2s plus 8 root 5s for the bottom middle. And then 3 root 7 plus 5 root 2 for the bottom right. Let's take a look at adding radicals, but first we have to simplify them. So the easiest way to do that is to do their prime factorization. Then we can combine like terms like we were doing in our previous examples. So 12 we know is really 2 times 6. 6 is not prime. 6 is really 2 times 3. 27 is really 3 times 9, but 9 is really 3 times 3. So let's see if we have any pairs that can escape. For our 12, we have a 2 who can escape. 3 gets left behind. For our 27, we have a 3 that can escape, and 3 gets left behind. So really, when I simplify this, I get 2 root 3 plus 3 root 3. Hey, these both have a root 3. They are like terms. So let's think about 2 plus 3. What do we get with 2 plus 3? We should have 5 root 3 for our answer. All right, let's take a look. Let's take a look at our next example here. So we have a 3 and then an 8. Well, 8 is really 2 times 4, which is really 2 times 2. And then I'm going to add, well, 45. 45 is really 5 times 9. 9 is really 3 times 3. Let's see who can escape. I've got a 2 that can escape. So I'm going to have 3 times 2, which is 6, and a 2 that gets left behind, plus I have a 3 who has a buddy and can escape, so 5 gets left behind, so 3 root 5. Are these like terms? No, so this is as simplified as it gets. I want you to try the rest of the page, okay? Try the rest of the page. Pause the video, try the rest. All right, you should have gotten 2 root 7x, 8 root 5b, 5 root 6, 12 root 3 minus 3 root 2. I cannot get any simpler than that. All right, multiplying square roots. Something else we have seen before, but not for a while. So some more cobwebs to clear out. We're going to multiply the square root of 3 by the square root of 6. My analogy was that this is like a prison transfer, right? So we have the square root of 3 times 6 now. So now they're together. I'm going to write this as a prime factorization. So 3 is a prime, but 6 is really 2 times 3. And the reason I'm going to do that is because I want to see if anyone has a buddy that they can escape with, so I can simplify this down. 3 has a buddy, so he can escape. So when I simplify this, 3 is just visiting, and my 2 is still stuck in prison. So our simplified answer is 3 root 2. All right, let's take a look at our 5 root 3 squared. So remember that squared means I have 2 of these. So I have 5 root 3 times 5 root 3. So let's do our prison transfer. 5 and 5 are both just visiting. So I'm going to stick them out front, 5 times 5. And then inside my prison, I have a 3 times a 3. So now let's see if there is anyone who can escape from prison, if they have a partner. Yes, our 3 has a partner, so our 3 can escape. That means I have 5 times 5 times 3. Well, 5 times 5 is 75. 75 times 5 times 5 is 25. Times 3 is 75. Gave away the answer there a little bit, didn't I? My bad. All right, I want you to pause the video here. Try the rest of the problems on this page. Pause the video, try the rest of the problems. All right, you should have gotten 8x root 2 for the top right. Middle left is 5 root 2. Middle is 63. Middle right is 2m root 7. Bottom left is 2 root 30. Bottom middle is 54. And then bottom right, you should have 120n square root 3n. All right, this is our last 2 examples for this 9.1 radicals lesson. I'm going to do 2 of these. All right, I'm going to do the top left and the bottom right. And it's using the distributive property to multiply radicals. So I'm actually going to use the area model just because I think it makes a really nice visual. So I'm going to give myself a nice box here. And I know that I have root 2 that goes on my left, and along the top I have a 5 plus root 12. So inside my box here, I have root 2 times 5. Is this 5 just visiting, or is he in prison? Just visiting. So we get a 5 root 2 here. And then in my next box, I'm going to have root 2 times root 12. Is the 12 in prison, or is he just visiting? He's in prison. So that means I really have 2 times 12, but we know 12 is not prime. So let's do our prime factorization in here, see if we can have anyone escape. So we're going to have 2 times 12 is really 2 times 6. 6 is really 2 times 3. All right, let's see if anyone has a buddy. Hey, I have a 2 here who can escape. So that means I have 2 root. 2 and 3 are stuck behind. They can't be buddies with each other. So we have 2 root 6. That means I have 5 root 2 plus 2 root 6. Are root 2 and root 6 like terms? No. So there's no combining like terms. So this is as simplified as it gets. Let's take a look at the bottom right corner next. So we have square root 7 minus 5 squared. Remember, squared means I have 2 of them. So square root 7 minus 5 times square root 7 minus 5. I'm going to do another area model here, so I'm going to give myself a nice big box. On the left, I have square root 7 minus 5. Make sure that subtraction sign turns into a negative by the 5. And along the top, I have square root 7 minus 5. So in my first box, I have square root 7 times square root 7. It's a prison transfer, so that means I have square root of 7 times 7. 7 can pop out. And then I have square root 7 times negative 5. Negative 5 is just visiting, so I get negative 5 square root 7. Now I have negative 5 times the square root of 7. 5 is just visiting, so negative 5 square root 7. Negative 5 times negative 5 in our last box, which is a positive 25. So when I go to write this out, my first box, I had 7. Then I have a minus 5 root 7 minus 5 root 7 plus 25. Do I have any like terms I can combine? Yes, I do. Negative 5 root 7 minus 5 root 7 is a like term, and then 7 and 25 are also like terms. So negative 5 gets me a negative 10, tack on my root 7, and then 7 plus 25 gets me a 32. You could also write this as 32 minus 10 root 7. Either way, sorry, off the paper. Sorry about that. Either way works. Got really excited that this was our last problem and didn't realize I was writing completely off the page. Try the other two. Pause the video. Try the other two. All right, you should have gotten in the bottom left 7 minus root 5 or 7 minus 1 root 5. And then in your top right, you should have gotten 3 minus root 15. Skills practice is posted. All right, skills practice is posted. 2 big ideas. Email me with questions.